Pleased now to introduce our two main speakers here on the data presentation. These are two leaders of the urban labs of the University of Chicago. Jon Guryan, Dr. Jon Guryan is an economist, Northwestern University professor of education and social policy, and co-director of the education labs. His research interests include the causes and consequences of racial inequality, among other topics. Dr. Monica Bhatt is the senior research director of the education lab and the crime lab at the University of Chicago. Her research interests include building capacity in educational systems and evaluating programs. And let me call on Dr. Monica Bhatt to begin the presentation.
Great, thank you, Alan, for that introduction. And thank you, Secretary King and Chief McDade, for your opening remarks. As Alan mentioned, my name is Monica Bhatt. I'm the Senior Research Director for the University of Chicago Education Lab. And we are very excited to present this work, which has been done in partnership with the co-authors you see listed here, in addition to many, many others, some of whom are on this call that made this work possible. So as Secretary King alluded to, and Chief McDade as well, we will learn a lot in the coming weeks, months, and years about the lasting effects that COVID-19 and the unique schooling experience that it has led to for America's school children, about what the effects will be for our kids today. But one thing we know for sure is that pandemics tend to exacerbate inequities that existed prior. And in American education, we have long grappled with stubborn, unyielding, persistent disparities along the lines of race and class that we have been trying to address for decades, if not longer. So what this graph shows is that the gap between students, for example, between rich and poor students, far outstrips that of what a high school student learns in math over the course of their entire high school career. So if we're going to be serious about addressing these persistent inequities, then we need to think deeply and carefully about how to do this so that some students are learning more than the average high schooler during their tenure in math and in other subjects as well, so that the red bar on the right might be eliminated and even get down to zero. So in order to think about what might be most helpful, imagine this scenario. You are a high school teacher and you are tasked with leading a classroom of 30 students. Some of your students might be working on problems that look a little bit like this, and don't worry, we're not going to make you solve for X here. But you might also have students in that exact same classroom who are still working very hard to understand problems that look more like this. And your job as a high school American educator in 45 minutes is to help support in a very, very detailed way each of your 30 students, no matter if they are working on very complex problems of math that are more akin to college level math, or students who are still struggling with basic concepts that are more akin to 5th or 6th grade level math. In some ways, that is an impossible task, and yet we have heroic high school teachers who wake up every day and do this not just once a day, but 6 or 7 different times a day. And I think that the innovation that Saga Education's high dosage tutoring program had was to basically simplify the tasks that teachers might have, which is to say, it might seem obvious that providing students with a tutor is the best way to help them learn math. But what Saga has done is to figure out how to provide that tutoring to students at a cost that is palatable to school districts and at a scale that can include thousands of students at once, and isn't so bespoke as to need a particular or impossible level of resources to actualize. The other thing that I want to say about this model, which is the model that we studied for the results that I'm about to share, is that it is high dosage tutoring, which is to say that not all tutoring programs are created equal, and this is not once a week homework help. The model of Saga's high dosage tutoring that we studied, for which I'm going to share effects on, was daily, 45 minutes a day. Students worked with a paid and trained tutor, and students got classroom credit for their math lab program, which is the class in which they worked with tutors, again, on a daily basis for 45 minutes a day during the school day. So that's a very, very different model than homework help, which I think is really important to keep in mind as we try to think about how to best utilize resources that are being made available for COVID relief and funding that might be applied to high dosage tutoring. What we find, and again, Chief McDade alluded to these results, what we find is that students gain an extra 2 to 3 times as much math learning in 1 year as a direct result of Saga's program. So we thought that this model was so promising that we studied it in partnership with Saga and Chicago Public Schools using a randomized controlled design trial, a trial design over 2 years with about 5,000 students over those 2 years. And what's important about these findings is that because of the rigorous research design, we're able to attribute these effects that we're seeing for kids who participated in Saga directly to the program of high dosage tutoring. What you see is in the first year, in the first study, we see what I might call medium effects, which is the first year that Saga was operating in Chicago Public Schools. And in the second year, we see really large effects in year 2. But consistently, we see that kids who are participating in Saga are learning more math than their peers, at least as measured by standardized test scores. Importantly, we also find effects on other outcomes. So we see about a 45% reduction in math course failures. And interestingly, we find a 20% reduction in non-math course failures. So overall, we see about a half a letter grade increase in math GPA, and we see increases in core course GPA as well. We did a survey of kids who participated in Saga or who were offered the chance to participate, and kids who got all of the other services that were available to them in the school, and asked about questions of grit, locus of control, to try to understand what might be driving these effects. We do see that kids who participated in Saga demonstrate higher levels of self-efficacy, in the sense that they are more likely to report that they are good at math, that they are good at school, that they like math. And we think that some of those results and that sense of self-efficacy, that I can do this, is what is driving these very large results that we see. And then finally, one other thing I want to point out is that sometimes in social science and education, we might see very large program effects at the end of the year, at the end of the program. And we're really excited about that, but the effects fade over time. We were interested in whether or not that was the case here. And what we find is that does not seem to be the case, which is to say, when we look at 11th grade outcomes and 11th grade test scores for students who participated in Saga largely in 9th grade, so 2 years later, we see a 0.22 standard deviation increase in math test scores, which means that kids, even 2 years later, are still learning 1.5 years more of math than their peers, which is to say that we don't find a lot of evidence of program fade out, or put differently, that the effects persist over time, even 2 years later. These findings are important when we look at the benefit-cost ratio of Saga. So here we show the benefit cost ratio not only of Saga education, but other programs that have been rigorously studied and are largely known and popular in education research, specifically early childhood programs, which are often thought of as high return on your investment avenues, or put differently, they're always thought of as really good investments. So there's sort of this well-known common ethos of, if you invest in kids, that's going to yield much more benefit for the dollars that you put in. What we see here is that on average, Saga has a benefit cost ratio of 4 to 1. What that means is that for every dollar that a school district spends on Saga, we see $4 of benefits in society that are generated. And we think that this number could be as high as $6 of benefits generated for every dollar spent. So we think this ratio could be 6 to 1, which is evidence that Saga Education's model of high dosage tutoring is just as cost effective as some early childhood interventions, if not more cost effective, turning on its head this idea that it is too late to intervene for kids when they reach high school and when they get to adolescence. A lot of programs that we've studied in the past for high school students have yielded disappointing results, and that has led to some pessimism to sort of think, oh, it's too late once kids are older to intervene and to intervene successfully. I think what this research suggests is that it's not that students are not able to learn and change and grow as they get older. It's that the model by which we are supporting them in doing that hasn't actually been the right one until now, but we do think that high dosage tutoring is one model that has a lot of promise in terms of these solutions. So we're pretty excited about these results, which are stunning on their own, but also because for the past few years, we have been working in partnership with Saga and Chicago Public Schools to understand whether and how you can get the cost to be even lower and still preserve effects, which allows you to serve even more students and still see these very, very large gains as a direct result of programming. So for context, the model that we study in the paper was with 2 students working with 1 tutor, again, every day, 45 minutes a day, as part and parcel of their school day. We recently studied a blended learning model in which there are 4 students working with 1 tutor, and kids are spending half the time with the tutor and half the time on an online platform, which is about half the cost of the model we study in the paper. And as a reminder, the model we study in the paper is very cost effective, so a ratio on average of 4 to 1. And the results of the blended learning model that I just described are very preliminary, but early indications suggest that the positive effects for students still hold. And that's exciting because it means that this version that we are presenting here is extremely cost effective. And if we are able to cut the cost in half, and we think we're able to preserve the benefits, that means that this blended learning model could be even more cost effective, which again is to say that you could serve more students and still realize and maintain those gains for the same dollar amounts. And again, as districts are thinking about the federal dollars and the COVID relief funding that is coming down the pipeline, thinking about how to support students learning, potentially to address learning loss, but also to keep continuing the work of addressing some of the persistent disparities that we've seen in education research. We thought that this was important information to share with you. So thank you so much for your time and interest today.